Hi there, everyone, or anyone, if anybody's watching, I hope that you do. I'm just going to take you through 5 questions from the Senior Maths Challenge. Well, I might just do 3 in this video and 2 in the next one, actually. But yeah, which I set for anybody interested just before the Easter holidays. If you notice those, it's a bit weird being in lockdown. But yeah, let's just take a look at this question here. Essentially, what we've got, for those of you who've studied planes before, we've got 2 planes. And if 3 points satisfy points on 2 planes, there are lots of different possibilities, really. But one obvious possibility is that the planes meet in a straight line. And on that straight line, they're saying that the mean of x, y, and z coordinates is always a certain value. Yeah. Now, it actually ends up being 10 here, but I'm going to show you what I would have done on a question like this. As soon as I see that the answer is always the same, regardless of which coordinate you take, well, I'm thinking, why don't I just pick a number then for either x or y or z and work out what the corresponding values of y and z will be, which is a bit of a cheating way of doing it, but I'm a natural cheater in life. I really can't get things through pure skill alone. So when in doubt, cheat, and so what I just say is, if it's going to be the same regardless of the value of x, y, and z, because they're saying it's always 10 regardless of x, y, and z, I'm just going to let x equal 1. And then what does that give me? That gives me 3y minus 5z is minus 4 minus 9, which I think is minus 13. Is that right? Yeah, my brain isn't going completely crazy, is it today? And here I'm going to have 2y plus 2z is 8. Oh, 2y minus 2z. Apology. Yeah, and then I'm just going to roll with it and solve these two simultaneously and find the corresponding values of y and z for when x is 1. I suppose I could times the second one by 1.5, giving me 3y minus 3z is 12. You'll probably solve that a different way, but it just means I can subtract now, giving me minus 2z is minus 25. So z is minus 12.5, z is positive, sorry, positive 12.5. The old sign error is creeping in there. And if z is 12.5, we get 2y minus 25 is 8. So 2y is 33. And so y is 16.5. And so x plus y plus z divided by 3, that's clearly how we're going to work out the mean, is going to be 30, because 1 plus 12.5 plus 16.5 is 30, divided by 3, which is 10. And so the answer is A for that first one. That's the way I approached that one. I think I saw Gabrielle do something different, which was fantastic. She had a much more comprehensive proof, if you like, because it would have been perfect if I had asked you to prove that the mean of x, y, and z is always 10. That's what she did. Mine is definitely not a proof that the mean of x, y, and z is always 10. Mine is a bit of sneakiness, really, where it's like, the question's indicating that the mean is always 10. Well, I'm going to take advantage of that fact. But yeah, the more sophisticated kind of way of answering this is to show that the mean is always 10. Okay, so let's try the next one now. I'm just going to try and clear the board, create a new board. Lovely. And I'm going to put on the next question, question 17. Okay, here we go. This one, okay, this one's kind of funny, really. You do a lot of work, or I did a lot of work anyway, and you end up with the answer of 0, yeah? Now, if you think about this, I suppose you could do this really quickly and think, if you've got 2019 consecutive integers, oh, excuse me, I've got the hiccups, 2019 consecutive integers, and the sum is 2019, can you see that some of those integers have to be negative? Because, if you've got the first 2019 consecutive integers, that will obviously add up to way more than 2019. And so in that list, you must have some negative consecutive integers in order to bring it back down to 2019. Well, if they're consecutive, and we're going to find a product of all those integers in the list, at some point you're going to be timesing by 0. And what happens when you times by 0? You get 0, yeah? Now I'll be honest and say I didn't do that. At the end I thought, why didn't I do that? But that's a super fast way of getting this answer, and there's no doubt about it, the logic works, it really does. I did it as an arithmetic sequence. I said, okay, I don't know the first term, but I do know the common difference, and I do know that the sum of the first. Now remember the formula, Sn equals n over 2, 2a plus n minus 1d. I actually use this formula because then I can say 2019 equals 2019 over 2, 2a plus 2018 times d. And then I actually worked out, well, that's going to be 4038 equals 2019 2a plus 2018d. And then I divided, so I've got 2 there is 2a plus 2018d. Sorry, I know D is 1, so sorry, just 2018 there. And then I can take that away, minus 2016 is 2a, and so a is minus 1008. So that's just telling me the first term in my sequence is minus 1008, and then I'm just adding up 2019 consecutive integers starting from minus 1008. And as you can see, I'm obviously going to get to 0, and so the answer is E0. It's very much a trick question. Not 0 factorial, that's just 0. But yeah, it's very much a trick question. It's kind of a funny one, really, isn't it? It's one of those ones where you're like, you get to the end of it, you work out the answer, and you're like, oh, I should have seen that straight away. But there we go. Or maybe you did see it straight away, but that's what happened to me. Okay, let's do one more. Let's do one more. What is it? Question 19. Ah, this one. Yeah. Okay, can I make this a little bit bigger so you can see it? There we go. There we go. Okay, so I like these kind of graph sketching questions. You've heard me speak many times about universities and extension papers like testing your ability, to sketch graphs, your talent for sketching graphs, because it's a really interesting talent because it's difficult to do. It can be really difficult to do. Now, how would I think about this? Well, when I'm looking at this, the first thing I'm thinking about is can y, let's, if you take the graph of b, for example, um, here you can see that y can't be negative. Yeah. Now, is there anything in this equation which is telling me that y cannot be negative? I don't think so, actually, because let's say x was, let me give you a quick example that y can be negative here. Say x was, I don't know, pi over 2. Yeah, then we're going to get sine of, oh, hang on, the root of pi over 2, let's say, yeah. Then we're going to get sine of pi over 2, and sine of pi over 2 is 1. Yeah, if we're working in radians anyway. Well, y could be minus 1, and that equation would be satisfied because you'd have minus 1 squared equals sine of root pi over 2 squared, yeah, and that clearly satisfies that equation. By the way, I've also got a coordinate there now, which is kind of useful, I think. It's worth pointing out. But this kind of question I definitely do kind of like, by elimination. So I've eliminated b there. B's nonsense. Y can be negative here. In fact, we can go further and say a few more things about this y squared and x squared business. What we can say is actually it guarantees a certain amount of symmetry and reflexivity in the graph. Is that the right word for it? Maybe not, but it certainly guarantees, okay, that when x, let's just looking at the x squared term, examining x squared. Oh, by the way, let's cross out b because that's clearly wrong. Examining x squared, yeah. Well, if you think about it, whether x is positive or negative, you're going to get the same y value, if you like. Well, there'll be two possible different y values, a bit like the one we just took. Yeah, we could have had positive or negative root pi over 2 would generate, yeah, if you had either of those values, then you definitely generate y is 1 or minus 1. Yeah, minus pi, 1 or minus 1. So when x is positive or negative pi over 2, y is 1 or minus 1. In fact, this reminds me of a circle or something like that, where you have lots of different x values giving you the same giving lots of different y values. It's a many-to-many mapping. That's exactly what it is. Many x values give you many y values, or exactly, in fact, two x values give you two different y values here. It's a many-to-many mapping. And so what I can see straight away is that, like, yeah, when x is, and this is going to be the first time y is 1 or minus 1, this starts to make it look like, well, maybe it's C, maybe it's A, maybe it's D, but it doesn't look like E to me, because when y should be 1, x could be positive or negative root pi over 2, but it doesn't give me anything for minus 1 there. That's what's telling me E can't be right. I'll give you another reason why E can't be right, though. It's for the same reason that A can't be right. Does 0, 0 satisfy... Oh, sorry, 8... Well, actually, I've changed my mind instantly here. What about, like, the origin? Because some of these graphs go through the origin, yeah? X is 0, y is 0. Does this satisfy the equation? Well, 0 squared is 0. What's sine of 0? Sine of 0 is 0. And so, yeah, this does satisfy equation. So, okay, I mean, like, that's definitely not right now. But now we're down to A, C, or E. Now, like I say, the reason why I would rule out E is because when x is, say, root pi over 2 or minus root pi over 2, you should get two distinct values there for y of 1 or minus 1. And we don't seem to be getting that. So, straight away you can rule out E there as well. What else could we do here? Well, you could also think of behavior, I guess, as x gets very large and y gets very large. Let's have a look. I think what I'm going to do, though, is look at this seems to be ruling out certain values, yeah. Between, I mean, if we're assuming that I was right here, this is where y is 0, yeah. So when if you look for the other solutions, let's actually be systematic here, yeah. I'm going to show you why, because I know the answer ends up being A, and I'm going to show you why it has to be A. We've ruled out some of them, but I want to show you why it has to be A. And as I'm talking some more, you'll see that the same reasoning applies to some of those I've already ruled out. If you're not completely convinced by my reasoning, maybe this will help you. Okay, when if we're looking at this point here, I'm trying to get these coordinates here and here, yeah, where it touches the x-axis, if you like, or here and here. It doesn't have to be on that graph, or here and here, yeah. I'm trying to get the x coordinates for where y is 0. Now, if y is 0, then sure, x can be 0, because you've got 0 equals sine of x squared. But then you've also got, now remember, whenever you do inverse sine on, you've got x squared equals 0, so x is 0. If you want, I'll do that line of reasoning if you like. Remember, when you do inverse sine of 0, you get 0 or pi or 2 pi or and so on and so forth. So we've got x squared equals pi, in which case x is root of pi, but remember it could be positive or negative, or x squared could be 2 pi, in which case y could be root 2 pi, positive or negative, yeah, and so on and so forth, yeah. So, oh, I don't know why I've got a y down there, that's a mistake, apologies, keep making these careless errors, it's crazy. Okay, so what have we found out there? Well, we've found out that this is likely to be where it first hits the x-axis on either side. Firstly, it's going to be symmetrical, as you can see, positive and negative. All of them, I suppose, look like possible candidates, apart from E, like I say, because it's not going negative on the Y at the same time as it's going negative or positive on the Y. You should have identical positive and negative Y coordinates for each X coordinate here because of the Y squared. It's as simple as that. It should have reflective symmetry, if you like, in the x-axis. It's because of this, actually. Sorry, I keep waffling on about different things here. Reflective symmetry in the x-axis happens when f of minus x, well, f of minus x, if you like, equals f of x, yeah? In other words, that's reflective symmetry in the y-axis, sorry. Reflective symmetry in the x-axis is this, minus f of x equals f of x. This equation will clearly have that because we're dealing with y squared. So these are both what y equals, and when you square them, you've got y squared. The equation's going to give the same x values for like positive and negative y values. I think it's intuitively obvious. I'm sorry if I'm waffling on a bit too much about it. Okay, so to finally decide what the answer is, yeah, there seem to be some values on A which are undefined, for the curve, and some values on whereas that's not the case for C. So if we look and we take this first to be root pi, then what we seem to be saying is the curve is undefined between root pi and root 2 pi. Well, let's see if that is the case. If I think of a number between the square root of pi and the square root of 2 pi, well, I think it's pretty obvious that square root of 3 pi over 2 is also in there. Let's see what happens. We're going to get y squared equals the sine of 3 pi over 2. And what is the sine of 3 pi over 2? Well, it's negative 1. You get y squared is negative 1. And that doesn't have any real solutions, does it? And that's why you're not going to get any values there. And that's why the answer is A. Yeah, it's a lovely, fun question, that. I really like that. I hope I didn't make it seem unduly complicated. Most of those ideas I'd be thinking about very, very quickly. There's loads of other ways you can do this as well. There really is loads and loads of other ways. But I think that's the way I'm going to settle on for the moment. Clearly showing you that certain values of x don't generate any corresponding value for y, and therefore it has to be graph A. Okay, thank you for listening. I'll do the last two in a separate video.